So in this video, I want to introduce you to the trapezium rule. But before we begin, I need to make it clear from the outset that the trapezium rule is not in the GCSE math specification. So you cannot get asked a question where it says something like, use the trapezium rule to estimate the error under this curve. Okay? You won't get asked that question. The trapezium rule is actually within A-level maths. So it's a technique that's used there and is examinable there. The reason why I'm including it here as part of the GCSE math specification is because it is a suggested method that students can use to estimate the error under curves. Okay? So for example, the AQA teaching guidance does mention that. So, how does it work? So in this video, I want to introduce to you how it works, where it comes from, what the formula is, and then in the next couple of videos, I'll show you examples of using it. So the idea is that we're going to split up our area into trapeziums, or trapezia. Now, in order to do that, the first thing we need to know is how do we find the area of a trapezium, okay? So if you have a trapezium, like so, one that looks like this, so right angle, and this length is h, and this length is, let's say, a, and this length is b, then the area is equal to 1/2 times h times a plus b. Okay, so that length plus that length times by the base and then halve it. Okay, this is how you work out the area of a trapezium. So what we're going to do is we're going to split this up into trapezia. So I'm going to draw vertical lines first. Okay. And then I'm going to join up the tops of the two lines. So you can see that one went underneath. That went just underneath. This one's going to go above. So the idea is that when you add up the areas of all these trapezia, you should get a reasonably good approximation of the total area. Essentially, those differences should probably even out. And if you want a more accurate answer, then you just use more trapezia. Okay? You make them thinner. So the key bit here is that each of the gaps here is exactly the same width. So each of your trapezia have exactly the same width, and let's label those H's. Okay? Now, the heights of each one I'm going to need to label, okay? So let's say I start with this height here, and I'm going to call that y1. So that's y1. And then this one is going to be y2, and then that one's going to be y3, then that one's y4, then that one's y5, then that one's y6. So I don't have to measure each of these. That's y7, and that one's y8. Okay? So I have 8 y's, 7 strips. 1, 2, 3, 4, 5, 6, 7. So there's 7 strips, but there are 8 ordinates, as they're referred to. Okay? But we don't need to worry about the terminology here. So, each of those areas I need to work out, and then I add them all up. So, the total area is equal to the first trapezium area, which is going to be 1/2. Now, remember what the formula was. So, it's 1/2 times h times by a plus b, so y1 plus y2. So, that's the first one. Then you've got the second one. So 1/2 times h times y2 plus y3. So that's the second one. Then we've got the third one, 1/2 times h, y3 plus y4. Okay? Then we've got the fourth one. So 1/2 times h, y4 plus y5. Then we've got the fifth one, 1/2 times h, y5 plus y6. Then we've got the next one, 1/2 h, y6 plus y7. And then we've got the last one, 1/2 times h, y7 plus y8. So it would be, you could just think of it as dividing it all up in trapeziums and adding all the individual trapezia together. You could think of it that way and do it that way. However, all of these area formulae have things in common. They've all got halves, they've all got h's. So you could factor out the 1/2 and the h for each of them. Okay? And then what you'd be left with is y1 plus y2. Then you'd have y2 plus y3. Then you'd have y3 plus y4. Then you'd have y4 plus y5. Then you'd have y5 plus y6. Then y6 plus y7. Then y7 plus y8. Now, notice how you've got y2 plus y2. Pair of those. y3 plus y3, pair. y4 plus y4, pair there. Two of those, two y6s, two y7s. Right? So the y1 and the y8, they don't have a pair. Okay? They're just by themselves. So you could write that as 1/2 h times y1 plus y8. So the first one and the last one added together. And then what you've got is all of these have been doubled up. So you've got two lots of y2, two lots of y3, two lots of y4, etc. So two lots of the rest of them. So y2, y3, y4, y5, y6, and y7. And so this is as short as I can get this formula to be. So what is it? Well, the area you could write down as this. It's 1/2 times h times by the first height plus the last height plus two lots of the rest of them. And this is the trapezium rule. Okay? That is the formula that allows you to do this quickly. So 1/2 h times the first plus the last plus two lots of the rest. Now, of course, there's more mathematical ways of writing it down and different ways of doing that. But I'm going to show you how you can use this formula to do this quickly. Okay? And so actually estimating the area under a graph can be done in a less onerous way.